Okay. Morning. All right. This is our first time, right? That we have class on Sunday. All right. Okay. The class will be 2 hours, right? I think. Okay. Um. So, how are you guys? Have you taken your breakfast? Right. Yeah. I'm just joking. Okay. Uh, be careful, guys. So for Muslim or others, so you're going to the Bazaar Ramadan, so be careful because I heard that there are many cases, right, about COVID-19. So some of my master student also get infected. So he think from Bazaar Ramadan. Okay, okay. So I hope that you all can be careful with that. Okay. And for your information, you got the email, I think, from school that all the subject, all the teaching will be conducted on online, right? Okay. So some of your subject required project based. So I think that one also need to be connected in online. Okay. Right. But for this subject, yep, we also have the a project that you need to do, but this one is the individually project. Okay. The project is very simple, right? The using the LDR, and then you need to construct the signal conditioning that on what we learned today, and then you will get the data. You will do some calibration, and if you want to have some advice, you can use Arduino circuit, right? Just to display the value and so on, right? Okay. So again, be careful, guys. Alright. So I'm also not feeling very well. I don't know. I'm not checked yet. Okay. Oh, okay. All right. So let's start our class. Can I start the class? Ready? If you are ready, so please start ready. I'm going to speed up. Okay. Right. Good. So we have learned about the most likely the concept of the measurement and also instrumentation. So we have learned a little bit about the transducer. Okay, there are many types of the transducer. So the transducer we convert it into useful value, right? For example, the changes of the voltage, right? And we have the input, for example, the changes of the temperature. So that's why I put the delta, right? So delta, that means is a dynamic input, right? It can be changed over time. That means the output also will be delta, right? It will be changed over time. Okay, and then normally the voltage that produced, right? For example, we have 20 degree. In term of millivolt, we have 2 millivolt, right? Voltage that produced from the sensor itself is very small, right? It's very small. So that's why sometimes you need a signal conditioning. Okay. So whether you want to amplify it, whether you want to filter the noise, or whether you want to convert it from the resistor to millivolt, or you want to convert it from resistor to current, or you want to convert from voltage to current, and so on. Okay, so this is a very important one, which is the signal conditioning. And you just not only use can have only the one signal conditioning, so you can have multiple signal conditioning. It depending on your application. Okay, right. Okay, signal conditioning, yep, it used to read the value from the sensor and then it convert it into the suitable value for others interface, right? So after this, maybe you will have second signal conditioning, or maybe you can have the comparator, right, to just compare the reference value and so on. Okay, so this is the function of the signal conditioning as a level change, whether amplify or attenuate. Attenuate, that means de-amplify. Okay, and conversion, right? Like I told you, if the output from the transducer is the resistance, so you can convert it into millivolt, for example. Okay, so other example is like Western bridge. Okay, so let's move on. Okay, linearization. Actually, we also can develop a signal conditioning circuit that used for linearization of our data, right? So maybe data that we got it is not linear, so we can make it linear, but the circuit will be quite complex, right? Quite complex, alright? So that's why we normally use a software lah to linearly run. Okay. And filtering, yep, this is what we will learn in the next topic. So we can filter out the input. So maybe at that time your input you got it is over time, right? So it has converted, right? Okay, millivolt from the sensor. So maybe at this time you got it all like this, okay? And then when you enter the signal conditioning, so you can get the output like this one, for example. Okay. So we can use it as the filtering. So like I mentioned before, there are many functionality of the signal conditioning. Okay, the rest it can be right here. Okay, and so on. Okay, for the Thevenin circuit, starting for this semester, this topic will be not covered lah, that's been out of topic. For your information, the Thevenin equivalence, or we call it is a Thevenin circuit, it used to simplify any linear circuit. Okay, for example, you have a complex circuit, right? This one we can say that is a complex circuit. So you can simplify it to be a simple circuit. Okay, right? So let's say this one is very complex one, then we can make it the equivalent circuit, which is only need one resistor and one power source. So this one you need three resistor, right? So three resistor and one power source. So when you use the Thevenin circuit, so you can only have two components. But in the practical application, we what we call it, we doesn't use the Thevenin's theorem or Thevenin equivalent, right? But because our circuit is much complex, so right now we don't need to simplify it. So sometimes our circuit we just use the IC chip and so on. So the Thevenin equivalent for me right now is not practical. Okay, so we can skip this one, right? So by the way, when we have our sensors, right? When we have our sensor, so actually our sensor will have the internal resistor. Okay, for example, our sensor detect the temperature, and then for example, right, is 20 degree, and it will produce the output is millivolt. Okay, the output is millivolt. So for example, it will produce 2 millivolt. Okay, all right. When we just ignore the internal, right, the internal resistance, maybe at that time we can get the 1 millivolt. Oh, sorry, it's not the 1 millivolt. We can get it 4 millivolt. maybe at that time, right? That means your sensor is a perfect, is a ideal one, okay? It doesn't have the internet circuit, but in practically, yeah, it have it, right? It have the internet circuit, so we cannot ignore it, right? So this is the RX, okay? And then that's why your voltage may be dropped to 2 millivolt, okay? Right. So this is the concept of the internet circuit. And then of course after this, on what you're going to do is you will this is your sensor. So whether you connected into the signal conditioning, right, OM, so your OM also will have okay. All right. Okay, so we just keep the Thevenin theorem and also a loading because that will not be covered, okay, or for this method. Okay, so let's look the OM. This is the important part that you need to be pay attention here. OM. So I believe this one you have learned in the other subjects, so we just recap it back, right? Okay. Right. Operational amplifier, OM. So OM, it can be used for voltage amplifying or attenuation. You can amplify it or you can de-amplify it. Okay. An ideal amplifier has the infinity input impedance. So infinity input impedance, that's mean here ZI. So ZI, it can be infinity. Okay. Set I, it can be infinity, right? And then a zero output impedance. So that's mean here it can be zero. So why? Because we don't want to lose anything from the input, right? So for example, our input Vi, for example, we put a 2 millivolt. So this OM, we configure it as the gain is 1000, so the output that we should get is 2 millivolt, right? 2 millivolt. We assume that this one, right, is equal to 0, this one equal to infinity, right? So if you inside the OM, right, so you have a very small resistor with the value of infinity, very large, right? And then it also have the output impedance, the value is almost 0. Okay. So for the OM, you can configure as the voltage follower, inverting, non-inverting, differential, and so on, different tether, and so on. Okay. We will look into that one by one. Okay. And then OM can be used to perform arithmetic operation like addition, subtraction, multiplication, and so on. Alright. So what the OM have is it have the V out, right? So normally, right, the V out, right, the output from the OM, and then you will have the gain that you can configure, right, whether you want to amplify or de-amplify, and then it will time with the V in, okay, we time with the V ins, alright. And then of course it have the saturation value, right? Saturation value. Saturation value, if you look at, this is the OM symbol. So it have two legs, right? And the symbol is like this, minus and plus. Okay, all right. And then this OM, you need to supply it to power supply. Okay. For example, you supply this one is 15 volt. Okay, 15 volt. And then your input, this one V1, V2. So your input that you want to amplify it, for example, is what we call it 2 millivolt, right? Okay, 2 millivolt. And then you set it your it's not 2, so maybe 15 millivolt. And then you set your gain, now you set is 1000. Okay, so what will be the output here, guys? What will be the output here? 15 millivolt, and then you set the gain is 1000. What will be the output there? Can you guess? Yes. Okay, some of you said is 15, yeah, 15,000, right? Okay. Which is 15 volt, right? 15 volt. Okay. Right. So by ideally, yes, you can get it at 15 volt because you supply until 15 volt ideally. But in practically, you cannot get a 15 millivolt. There will be some of the offset value, right? Because our OM is not ideally enough. So maybe at that time you will get it is around it will be plus minus 0 point something. You will got it is 14.2 volt. Okay. All right. So if your application you need the value is 15 millivolt, that means you need to increase this one. Maybe you need to put it 20 volt and so on. Okay, that's what we call it is saturation. Okay. All right. So far so good. Any question? Any question, guys? No. So far so good. All right. Okay. Good. Good. All right. So let's look. Yeah, this is your OM, right? OM is kind of like the IC. Okay, this one. The symbol is minus and plus. So actually, it also have the supply because the OM is the active components. That means active. You need to supply something to make it active, right? When I ask you a question, Abra Hussein, what are you doing? Okay, that means I active you. Okay, all right. And then you have the offset now. All right, this one NC is not connected, right? You don't need to do anything. And then this one where you supply it, so it have the positive V and minus V. You also can supply the positive voltage and also negative voltage. Okay. And then it have the inverting, right? Inverting input. Yep, this one we call it inverting input. Inverting lah, right? So this one we call it is non-inverting. Okay, and then this is the output. All right. And then offset none and offset none normally we doesn't use this one lah. Okay, so we just need to have only this one and also this thing. Okay, in order to get it output. Okay. Oh, sorry, this one and also the output here. Yeah. Okay, so let's look the basic configuration, right? Which is the inverting. Okay, so when you construct the OM, right? This is your OM. Then you have the input, right? Input going to the inverting, right? Minus. Then you have one resistor and two resistor, right? First one resistor, two resistor. So then this one we call it as the inverting circuit, right? So what it do is it will convert it from it will invert it, right? For example, if your input, right, the first cycle will be plus, and output you will got it will be minus. It will invert it, right? The waveform. And then the next one, the input will be minus, so the output will be plus. Okay, so whether you configure it as the amplify or de-amplify, it is depending on the R1 and R2 value. Okay, all right, so let's go this. Okay, let's do this one. So let me do it again. Okay, in order to draw the inverting circuit, so what you need to do first is you need to draw the ON first, right? This one. ON actually have a 3 leg, okay? 2 for inverting, 2 for input, and 1 for output, and minus plus. So what you need to do is for inverting, plus is going to negative, and this one going to input V1, and then it have a feedback resistor, okay? So sometimes we call it as the RF, right? Or maybe you can put it as R2 because this one is R1, okay? And then the equation, right? This one is the V out. The equation will be V out. The concept is the gain you time with the V in. Okay, so the gain right here is R. I put it is R2, right? Okay, R2 over R1. You time with the V in, so V in. So this is the V out. Okay, all right. So the symbol for this one is only to show the it will invert, right? It will invert only, right? That means if your input is positive, so you will got it, the output will be negative value. Okay, so the gain here, gain GAIN is equal to R2 divided by R1. Okay, all right. So let's test your understanding. So if I have the input 0.1 volt, okay, and then I want to have the output is 10 volt. I want to amplify it, right? Because we have 0.1, I want to have 10 volt. So maybe the Arduino need to read 10 volt. Okay, all right. So what will be the gain, guys? So this one, we need to time by 100, right? Okay, good, right? 100. Okay, that's mean your R2 right now maybe is 100K and R1 is 1K. Okay, so this one is R2 over R1. All right. So the same thing, if I want to de-amplify it, I have a 10 volt here. I want to get it 0.1 volt here. So what I need to do is I can use 1K and then I need to multiply with 0.1, right? Okay, 10 times 0.1, I will got it 0.1. Sorry, so this one is 1 volt. Yep. Okay, 10 volt, I want to de-amplify it to 1 volt, so I need to multiply with 0.1. So 0.1, that's mean 1 divided with 10, right? Isn't it? Right or not? Right, right? 1 divided with 10, so that's mean maybe you can have the 1K and also 10K, right? For the value of R2 and also R1. Okay, so it is depending on your application, what you will need. Okay, so this is the inverting. Okay, let me ask you again. So if we have input 0.1, the output that we can get is 10 volt, right? Is it we get plus 10 volt or minus 10 volt? Come on, guys. Plus or minus? Plus or minus? Yes, it's minus, right? Good. Wow. Any of you are active right now? Elvin, okay. Johnny. Yes, Papa. Okay. Alright, so what you get it is minus 10 volt. So how to make it positive 10 volt? Guys, how to make it positive 10 volt? Can you guess? how to make it positive 10 volt. Our input 0.1, but we want to get it positive 10 volt. Plus 0.1, oh, how to do that? Edwin Silvanus. Plus 0.1, what do you mean plus 0.1? How are you going to get positive 10 volt for the output? Okay, how to get it? So we have the previous, alright, the previous inverting circuit. Okay, this is R2, this is R1, this is V in, this is V out. So because we set it the gain is 100, so that means maybe you just need the 100k for R2 here, and for R1 you just need 1k, 1 kilo ohm, right? 100 kilo ohm. Okay, so if your input right now is 0.1, so you will got it minus 10. How to get it plus 10? How to get it, guys? You have learned this one, right? Anyone who want to guess how to get it plus 10, how to get it positive? Anyone who want to guess? Okay. Anyone? So what you need to do? Anyone want to guess how to get positive 10? Nobody want to answer that? Said don't know. Oh, sad. Okay. I don't know, doctor. Tak. Guys, are you still there? Wake up, wake up. No idea, doctor. Okay, that is the answer that I want. No idea. Okay, then I can give you the idea. So, what you need to do is, you just need the another inverting amplifier, right? I am right. Another inverting amplifier. Okay, so this will be your V out, right? Final V out. Okay, I'm right. Okay, so what you need to do is, on this value, so you just need to choose any same value, 1k, 1k. Okay, so what will be this gain? Will be times by 1. 1k divided by 1k, it will be 1. So minus 10 volt, you time by 1, so actually you got it positive 10 volt here. Okay, that will be the answer. Okay, do you understand or not? Wow. Wow. Okay. Right. So that means you just need a second inverting amplifier. Then you just use the same value for both resistors. Okay. All right. So this is the inverting circuit. Okay. So let's move. For the non-inverting amplifier, that means you can amplify it, right? You can use for amplify it, but it will not invert it. Yeah, this is a good thing. Okay, because your input is to be a positive, that means non-inverting. So what it does is if your input is positive at the first cycle, so you will got also positive. If negative, you also will got it negative also here. Okay, so the circuit will be like this, right? The positive, you put it at the V in, and also the other one you just put it at the ground. Okay, and then the formula, it will be just like this one. Okay, all right. So let me show you, right? How you going to draw the non-inverting if you doesn't remember the circuit, right? How to draw it? Okay, let me say you something that's mean any of the OM configuration, right? Like on what we have just learned is the inverting, right? Any of the OM after this, right? Any of the OM configuration, it will be from the inverting circuit. Alright, okay, so let's draw the inverting circuit first. So this is the inverting circuit, minus, plus, going to ground, and also it have the feedback resistor, and also it will have the input V in, R1, R2, and also V out here. This is the inverting circuit, right? Inverting circuit. Okay, so now how to make to non-inverting? How to make the non-inverting circuit? How to make it? So the tip is you just switch this one. Here go in here, and here go in here. That's it. Right? That's it. In order to make the non-inverting circuit. So in this case, right here, put it here and here. So this one, I put it here to the ground. So this one is the V in. Now you make it as the non-inverting circuit. Okay? It's easiest, right? So all circuit is from the inverting circuit. Wow, Johnny. Okay, wow. Okay. Just put the clap for me, right? Okay. So, right. Next, what will be the formula? So the formula is V out is equal to 1 plus R2, R1 is need to time with the V in. Okay, so we know that the function of the amplifier, it can be amplified, right? And also it can be attenuate. Attenuate, that means the de-amplify. So my next question is, right? Oh, before that, this is the gain, right? So your gain now is 1 plus R2 over R1. So if you want to make it, the gain is equal to 100. So what you need to do is 1 plus 99k divided with 1k. Okay, so you need to choose the value for R2 is 99k, and this one is 1k. Okay, that is the concept, right? Okay, so now my next question is, if I want to have the gain, I want that means this one you amplify, right? Okay, this means this one you amplify. Okay, I want to make it attenuation, right? That means de-amplify. So the gain that I want to have is 0.1. So what will be the value for R2 and also R1? Okay, this is my next question. I want to make it attenuate, de-amplify. Mean I will time with 0.1, this one we time with 100, right? Johnny. Okay, Johnny said the value of the R2 and R1 is minus. So that's mean Johnny said Okay, R2, the value will be minus 99 kilo ohm. R1 will be 1 kilo ohm. Okay. Alright. Is it correct, guys? So that means we need to use the resistance value is minus 99k. Yeah, now you're asking me, right? But how to make negative? So maybe after this you can go to the electronic shop, or you can email them, or you can chatting with them. Hi, and I got the resistance with the value of negative 99k. 99 kilo ohm, and then you will get it. What is it? Oh, I don't have the symbol. You get the slap emoji, right? Pam. Okay, go and learn again. There is no resistance value with negative value, right? It's only from 0 kilo ohm until infinity kilo ohm, until the infinity ohms, right? There is no. Okay. Oh, bottom makes the big value. Okay, so you want to make a big value. Okay, that's mean, what is it? You want 1k, R2 is 1k, and R1 is 100k, is it? So you will got it is 0.1 here. So 1 plus 0.1. No. No, I messed up. Okay. Alright. Johnny eating sugar, right? Okay. So what is mean, guys? What is mean? It mean that the non-inverting circuit, it cannot be used for attenuation, right? The concept is it cannot be used for attenuation. Okay, all right? Because of this guy. So whatever is it that you use, right? For example, this one, you will get a 0.1, but it still amplify it, right? 1 plus 0.1, that means the gain will be 1.1, right? It still amplify it. The basic gain is 1, and then now it become 1.1, that means you will amplify it, right? Okay, so time 1.1. So whatever value is it, it will time with 1.1. So it cannot be used for the attenuation. Okay? Right. Is it clear? Alright. So if you want to use for the attenuation, that means you need the inverting circuit, right? So your input need to be go to the minus terminal, right? It's not the positive terminal. Okay, so yep, let's go for the example 5.2 before we take a break. Okay, so show how the OM can be used to provide an amplifiers of gain plus 100. Okay, so now it want to have the gain plus 100. Okay, the input had the input the signal in input signal had the input impedance 1.5 kilo ohm. Show how this can be done by using both inverting and non-inverting. Okay, so this one you want you to get it our gain is positive 100. That's mean the overall gain, and also the input impedance R1 is 1.5. Okay, let's do this. It's a simple circuit. Okay, all right. So the first one is the inverting, right? So inverting configuration. So first of all, the inverting minus plus. Okay, now it have the feedback resistor and also the input impedance, right? Resistor, because the question said that it have the input signal have the input impedance for 1.5k. Okay, done. All right. So right now, positive terminal is going to ground. So we have this one V out here, and we have this input, right? Okay. Then the question said that how to make the positive 100 gain. Okay. So what is mean is this one you will configure is the 100, right? It's the 100. So that's mean 100 R2 divided with R1. So this one is R2, this one is R1. So what you will get it here is you can use R2 you can use 100K, and R1 you can use 1K. Okay, so this is how you got it. And that's mean this one will be 100K and also 1K. Okay, all right. But the question want you to have the positive gain, because of this one is actually you got it is negative output. So what you need to do is you just need another inverting circuit, right? Another inverting circuit like this one. So you have here minus and plus, this one going to ground, this one is the feedback resistor, yeah, and this one you can use 1K and 1K. Okay, right. So this one you will got it the V out at the final one. Okay, so this one you gain you time with 1. Okay, all right. So this is how, if you want to get a positive gain for 100. Okay, all right. The concept will be, yeah, like this. Okay, so this is the first question for inverting. This is the easiest one, right? Okay. Okay, the next one is for the non-inverting, right? Yeah, this one is nothing lah, right? Okay. For the non-inverting, it will be simples, right? So you just draw first the inverting. Yep. Minus plus, plus going to ground, and this one is going to here, going to here. This one is B in, and R2 and R1. This one is the V out. Okay, so this one the inverting. So to make it the non-inverting, so you just change between these two. So this one going to ground, and this one is the V in. Okay, so because the V in had the input impedance here. Oh, I'm sorry. So right now we cannot use this one is 1K. So because the question said that it have the input impedance 1.5K, so that's mean this one is 1.5 kilo ohm, right? Okay, so we need to set it here is 1.5 kilo ohm. How to set it, right? Okay. Sorry guys, sorry, my mistake. So this one is 1.5K. So in order to get it, yep, then we need to find the value for R2 here. Okay, so now your R2 value is equal to 150 kilo ohm. Okay, right. So this one, sorry. Okay, I hope that you don't mind. Okay, 150 kilo ohm. Okay, so 150 kilo ohm divided 1.5K, so you will got it 100, right? I think like that. Because the input of the voltage. Okay, is it okay, guys? Okay, good. So now for the non-inverting, so the input impedance will be like here 1.5K, and then you need to find this value. Okay, for the gain is 100, right? So this one will be easiest one. So the gain now is equal to 1 plus R2 divided with R1. So we want the 100. So 1 plus 99k divided with 1k. So that means our R2 now is equal to 99k. Our R1 now equal to 1k. So the answer will be 99 kilo ohm and also 1 kilo ohm. Okay, this will be the non-inverting configuration circuit. Okay. Any question, guys? Yes. For this non-inverting configuration is we also consider the input impedance, but the input impedance will be like this one. Okay, because we don't want to use to lose the input, right? Yes, to the ground, because we don't want to lose the input. If we put it, the resistor is at here, so that means we have lost little bit the V in here. You understand it? So that's why we put it like here. Okay, can you get it, Johnny? Yes. Okay, because the voltage is at here, right? For example, this one is 2 millivolt, so we also will get it here 2 millivolt here. Okay, that's why we don't want to lose it, so that's why we put it, the input impedance the resistor will be into the ground. But actually, if you don't need the input impedance resistor, so it's okay. So you just need to connect it directly. Okay. All right. So let's take a break for 10 minutes. I will see you again at 12. Okay. For the next topic. Okay, guys. All right. So you can have a drink first, right? Okay. Good. Lim Jun Tai, or you make the tortoise, right? Tortoise. Okay. All right, almost 10 minutes. Have you eaten? Have you drink? Okay. Daryl John. Right. Johnny. We we only have Johnny, right? That respond. Why the rest? Guys, why the rest? This class is not for B40, right? Okay. It can be T20, T21, right? T or K or whatever is it. Ah, now everything want to be viral, right? Okay. All right. So let's move on. Okay. So we will have another topics. This one. So uh, we have learned two configuration, inverting and non-inverting, and we will look at another three or four configuration of the OM. So what can we do? We just need one IC, but we can do a lot of configuration on that. Okay. So the next one is the voltage follower. Yeah, voltage follower is sometimes is very important, right? When you construct your circuit practically, yes, you will need the voltage follower, but you have to test it first, right? Whether your sensor can support the actuator or the output or not. Okay, right. So let's consider this. Some of load with low input impedance, right? Like speaker echo. Okay, some of load, right? So when we talk about load, that's mean, right? You have the sensor, and then your sensor will activate, right? We try to drive the load, right? We try to drive some actuator. Okay, for this case, we have a speaker, right? Okay, this is the speaker. The speaker have the resistor. Yeah, you put it, it's 8 ohm, right? Okay, and then you put it in your sensor. Okay, so this is your sensor. For example, okay, and then this one you connected to ground. Okay, for example, is the uh, your sensor detect temperature. So when the temperature is high, so it will activate this speaker, right? Or buzzer, something like that. Okay, so this sensor is converted from the degree, right, to current. Maybe in that time is micro ohm. Okay, because of the load have very low input impedance, so it can go up to 0 ohm. Okay, so it will draw a lot of current here, right? A lot of current here. So that's mean you will lose the data a little bit. Okay, you will lose of data. So that's mean maybe at that time you cannot activate the speaker. Okay, because uh, your sensor it cannot convert it into the current anymore. Okay, all right. So based on the formula V equal to IR, so V over R equal to I. So when your resistance is too low, so that means it will have need a voltage a lot. Okay, so that's why we need the voltage follower. So the concept of the voltage follower, the input, right? The output from the sensor, which is the Vin, right? That we go to OM. So you don't need any resistor here, right? You don't need any resistor here. So you just need wires, right? From this one, you just need wire connected to minus. Okay, let's look the importance of the voltage follower. Why? Why is very important. Okay, if we look at these two cases, right? So this one, we have a supply, right? We have a supply is 10 volt. Okay, then we have two resistor here with the same value, which is the voltage divider concept. We can get it is 5 volt and this 5 volt. Okay, so we have a load, right? This one load that have the resistance 100 ohm, which is motor right here. We have a motor here. How to make the motor? How to make? Okay, so like this one is the motor. Okay, so the motor need a 5 volt to operate. So if we look at here is 5 volt, that means the motor is parallel to the resistor. We will get it 5 volt here, right? By theoretical, yes, right? We will get the 5 volt here, right? By logically, yeah, because the motor is connected parallel, right? But when you construct in practical, right? So you will see that no, the motor doesn't work. So when you measure it, you only get it is here, you only get it is 98 millivolt. So what will be happen? It doesn't work. Okay. However, when you connected to voltage follower here, so this one is 5 volt, and when you measure your motor voltage, you will got it 5 volt here, so your motor can work. Okay. So why? There are a lot of explanations there, so I'm not going to show you. Alright, so the concept is this one is the infinity ohm. So you will see that when you do some calculation, you will get it. Yeah, in theoretical you can get 5 volt, but in this case I just want to show it to you is sometimes you need the voltage follower in order to make the actuator works. Okay, can you get me? Can you get me, guys? The important of the voltage follower. Okay, good. All right. So a simple thing to draw the voltage follower is very simple. All circuit is from the inverting, so you just need this one. Okay, inverting circuit, right? So except before this, the inverting, you have the resistor, right? Okay, this one it doesn't have the resistor. Okay, it's just a wire, and this one your V in, and this one your V out. Okay, alright. Okay, so the OM right now have the very high input impedance here. Okay, alright. So the next one is the summing amplifier. Signal from two or more sources must be added to obtain output signal that is proportional to the sum of the input signal. So that means you can have multiple input that can go to the OM, right? Go to the inverting terminal here, which is minus, right? For example, like this one, you can have V1, V2, and also you can have another V3, okay, another V3, and also you can have the another V4, right? This one the R3, this one R4. You can add it together, right? And then you can amplify all the signal. Okay, so the example application, right, of the summing amplifier, right, where you can get it at the when you go to the mall, right, when you go for the date, right, with your girlfriend or your boyfriend, and what you will do when you go for the date, you go to watch movie, right, Batman. So how about the Batman, and then we have another one, what is it, the new films, what is that, is it's about the Spider-Man, that one. Guys, okay, alright, so the example of the summing also is like when you go to karaoke, right? So your friend your friend have the mic number 1 here, and other friend have the mic number 2, and your girlfriend have the mic number 3, right? So all the input is going to be amplified, right? It's going to be OM, right? It's going to be summing, amplify it. So this is the example using of summing circuit. Okay, so the formula that you have to remember is for the summing is given to you G1, G2, G1, B1, G2, B2, and so on. And the gain is also depending on the feedback resistor to each of the resistor. Okay, each of the resistor. So on what I'm going to ask you to pay attention here is you will look at the output of the summing. It will be inverted, right? Because the input is going to inverting, so it will be inverted. So let me give you some tip how to draw the summing circuit. It's very simple. All the circuit is from the inverting circuit. If you forget it, so you just draw the inverting circuit first. So make it this one RF and this one is V1 R1. Okay, this is the inverting circuit, right guys? Inverting circuit. So in order to make the summing circuit, how to make it, right? I'm so sorry guys, our class until 1, right?
Yes.
What I can see, yes, okay. Most of your friend has left this class. Okay, good. So how to make the summing? So you just need another input here at this point, right? So this one V2 R2. If you have another input which is the V3 R3. Okay, yeah, that's it. Let's make it the summing circuit. Okay, all right. So how about the formula? Formula is quite simple. So V out, I want you to remember this one. It will be have the minus because it will be inverted, right? After this, then we have a G1 B1 plus G2 B2 plus G3 B3 plus blah 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 Gn Bn. Okay, so you just need to remember this. So what is mean by G1 is only RF divided with R1. What is mean G2? RF divided with R2. G3 is RF divided with R3. And also you can have the Gn, which is Rn divided with Rn. Rn, Rn. Rfn. Oh, sorry, Rf. Okay. Rf divided with Rn. That is the formula that you need to remember. Okay, so let's look example 5.3 to make it clear, right? To make it clear. Okay. Right. Develop an OM circuit that can provide an output voltage related to the input voltage by Vout 3.4, Vin plus 5. Okay, plus 5. Right. So what is mean by this is maybe at that time you just need input, right? So you want to have this kind of the formula. Maybe you have the input right now is Vin, right? And then you want to have the output here, and then you got it this line, right? So and this line it will give you the equation V out equal to 3.4 V in plus 5. Okay, something like that. Okay, all right. So what you need to do is develop an OM circuit. So if we look at here is it have a plus symbol. So that's mean it will have two input V in and something here. So that's mean you can do the summing circuit, right? Okay. So what you will do is the first one is V out the formula for the summing circuit G1 V1 plus G2 V2, okay, because we assume it's only two input, right? 3.4 V in plus with 5 something, okay, so there are two input there. Then the next is bring the -1 to here first. So what you need to do is minus V out equal to G1 V1 plus G2 V2. Okay, right. After you bring that minus, so now it's time you to compare with the equation that shown here. So compare it, right? This one is V out 3.4 V in plus 5. What we can do is we can compare it, right? Okay, so now, okay, become here. So come here, and also this one is time 1, right? So now become here. Okay, so let's move. When we compare it, so we can get it is G1 here is equal to 3.4. Okay, and V1 here is equal to V in. Alright, so G2 here is equal to 5, and also V2 here is equal to 1. Alright, so your input V1 is equal to V in, the symbol, and V2 is equal to 1 volt. Right, so the next is, how about the resistor value that you're going to choose? Okay, so G1 is equal to 3.4. So G1 by definition is equal to RF divided with R1 equal to 3.4. So that means you can use the value for R1 is 34K, R1 is 10K, right? In order to get 3.4. So I got it here is RF equal to 34K and R1 equal to 10K. Okay. Alright. That's it. The concept. And then G2 is 5 volt. So definition G2 RF over R2 equal to 5. And then RF is 34K divided with R2 equal to 5. So that means your R2. Okay. What is it, guys? The value for R2? Can somebody calculate it for me, please? Wow. Okay. Johnny, good. Alright. So this one is 6.8K. Okay, thank you very much. Done. So we got all these values. So now it show you develop. That means you need to design the circuit. You need to construct the circuit. So what you need to do is, first of all, draw the inverting circuit first. So this one going to negative. This one have a feedback resistor, and also this one have the R1. This one the RF. So because we have two input, we have another resistor R2 V1 V2. So this one is the V out. Alright. So right now is the value RF is 34K, R1 is 10K, R2 right now is 6.8K. V1 is equal to V in, V2 is equal to 1 volt. Okay, right. So when you use this formula, you will see that I got it minus, right? You see this one, this guy, yeah, minus, right? Okay, so I got it minus. So how to make it positive V out? Because this one is need a positive V out. Okay, so that means you just need what, guys? You just need what to make it? Okay, Johnny, thank you. Connect with one more inverting circuit. Yes, Thank you, Johnny. Okay, so this one you connected to another inverting circuit. Okay, positive going to this, going to this. So this one is 1 kilo ohm, 1 kilo ohm. Then you will got it is positive V out. Okay, this is how you design your circuit. Alright. Okay guys, is it clear? Okay. Clear guys? Okay, good. Alright. Speed up more. Terang. Okay. Okay, this is the example of the summing circuit. Okay, so let's look another one. Have you copy? Or you have the master copy? Okay. Alright, so let's move for the differential amplifier, right? For the differential amplifier. Okay, so we can have another configuration for the OM for check the difference, right, between of the two input. Okay, we can check it, right? Okay, and then we can amplify it. Okay, to find the formula between output and input, divide the circuit into inverting and non-inverting OM. So that means we will use these two terminal lah. Okay, so the circuit will be like this. You have one input impedance for V1 and R2 for input impedance for V2, and we have the feedback resistor and R3 here. Okay, so and then this one show you the blah 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 how to derive and so on. So you just need to remember is only this formula. Okay, only this formula. So in order to use this simplified formula, you need to make sure that this value and this value it will be the same, and also this value and this value will be the same. Okay, so let me recap it back. So how to draw the differential amplifier? So all is from the inverting. So we can draw the inverting first. Okay, so this is RF, this is R1, this is V1, right? So this is V out. Alright, so to make it the differential, so that means we will use both terminal, minus and plus, inverting and non-inverting terminal, right? So what you need to do is you will have another input V2, this one R2, and after that, at this point you will pull down to ground. Okay, so the value that you will use is RF. So I like to make it, this one is R1. Okay, so both will be the same. Okay, RF, RF, R1, R1. Okay, and then the formula right now it will be V out. If you choose the same value for both resistors, so it will be only RF over R1, but you need to make it V2 minus V1. Okay, so this guy minus 1. Okay, so RF and R1 is the gain. Okay, the gain RF over R1 is the gain. So you can find the differentiate between the two voltage, two input V1 and V2. At the same time, you also can amplify it. Okay, that's the advantage of using the differential. Okay, all right, and let's look the example 5.4. Okay, a sensor output range of 20 to 200 millivolt. Develop signal conditioning so that it becomes 0 to 5 volt. Okay, the circuit must have very high input impedance. Okay, so in this case, you need to understand the concept. You have the sensor, like say like this is your sensor, so the degree, and then you put it one of signal conditioning that we do not yet. Okay, and maybe this is your microcontroller or Arduino and so on, or analog to digital maybe. Okay, so what it does is uh, the sensor, it will produce the output, which is 20 millivolt until 250 millivolt. Okay, and then you want to have the output, right, of your signal conditioning between 0 volt and 5 volt. Okay, you know what it means, right? Okay, so what you will do is you will plot the graph, right? You will plot the graph. Okay, this is my graph. This is the V in, this is the V out. So now is 20 will be, this one is 20, 20, yep, you got it, 1 point, 20 and 0. And this one is 250, then you have the 5 volt here. Okay, so now you will got it, is kind of the graph that show the relationship between V out and V in. Then when we solve it by using the linear equation, so you will got it is here is V out equal to 21.74 V in minus with 0.435. Okay, that's the concept, right? Okay, can you get it? Can you understand it? So far so good. Okay, okay, all right. So after you get it, this equation, so you can decide whether you want to use a summing or differential. You can decide. So let's have you now use the differential. Okay. So the formula of the differential, will be V out equal to Rf divided with R1 U time with V2 minus V1. This is the formula. Okay. Now you have the equation V out equal to 21.74 V in minus 0.435. So in order to compare it, you need to factorize this one first. So V in minus 0.435 divided with 21.75. Now in this case 21.74, you got it V in minus, this one I believe got it 0.02. So this is the V out. Okay. Then after you factorize that one, so you can compare it, right? So this one with this guy, and this one with this guy, and this one, take it the minus 2, go to this one. Alright. Okay. So let's move here. Now I got it is the RF over R1 equal to 21.74. So now I can use 274K for RF. For R1 I can use 100K. Okay, agree? Agree, right? Yes. Okay, good. So next is the V2. Okay, the V2 will be equal to V ins. Okay, done. And also minus V in. Don't forget to take minus, right? Minus V in equal to minus 0.02. So, minus V1. V1 equal to 0.02. Okay, we are done. Then we can draw the circuit, right? We can draw the circuit for the uh, differential. So differential is from the inverting. So let's draw the inverting first. So this one is V1, R1, so RF. And for differential two terminal that you will use, V2, don't write the R2. So write the R1 because we use the simplify formula. This one going to ground, this one RF. And the rest one is the VR. So what will be the value? V1 is equal to 0.02 volt. V2 is equal to V in. R1 is equal to 100k. R1 here equal 100k. RF equal to 2174k. RF this one 2174k. Then you will got it, the output will be 21.774 V in minus 0.435. Okay, all right. Okay guys, all right. So the question said that to design for the high input impedance, so you can add a voltage follower, right? So for each input, you can add the voltage follower here. So how to draw the voltage follower? Yep, minus plus. Okay, here, then you can have the V1. Okay, V1 here, which is the 0.02. This is how you added the voltage follower, right? Okay. So in order to make the input have the highest input impedance. Okay. So this one is the V2. And then minus this one from here. Okay. Alright. That is the circuit, right? Any question, guys? Any questions? No? Okay, good. Okay. So the last one will be yep, voltage to current converter. Yep, we sometimes we use it, sometimes we doesn't use it, right? So in order to make it the voltage, how to convert the voltage to current, so you will use this kind of the configuration. Okay. Alright, current to voltage converter also like this one. Okay. But normally we so sometimes we use it, right? It is depending on your application. Okay, and the last one will be the comparator. So the OM also you can use as the comparator. So so the comparator, that's mean sometimes you want to make it a level, right? So show that your input, right, cannot more than your level, right, your reference. Okay, so if more than your reference, that means you will do something, whether you want to trigger an alarm or you want to trigger buzzer or output and so on. So this is the comparator. So what it do is it will compare two analog voltage on each input terminal. Okay, so if you can look at here, you have the input and you also can have your reference that you set the level. Okay, all right. So depending on which voltage is larger, the output is in the digital signal will be. Okay, 1 will be high or 0 will be low. Okay, it's mean like this. Okay, you have the comparator. Actually, the comparator is also ohm, right? Okay, but I like to write the symbol will be like this. Okay, before that you write minus and plus, right? So now make it plus and minus. So that means we know that this symbol is for the comparator, right? But it use the same chip, right? So you also can use the LM 741, right? Okay. So for the comparator, the most popular famous chip, right, which is LM324. Okay, so what it have is here it have the V in, and also this is our V reference that we set it, right? And the comparator also you need to supply the voltage, right? So for example, sometimes it write the symbol in VCC, right, or VDD. So for example, you set it to 5 volt. Okay, all right. Then the output will be in terms of the digital value. Okay, output. Okay, so let's look this. So if your V in is more than your V reference, so you will get the output is 1. 1 is referred here is 5 volt. So it will just select 5 volt or ground. Ground that means 0 volt. Okay. So if your V in is less than V reference, you will got it 0. We got it low, and then it means you will got it 0 volt. Okay, that is the concept. That is the concept. Okay, whether 1 or 0. So 1 in terms of the voltage, when you measure it, it will get it the highest one, 5 volt. 0 that means is 0 volt. Okay, so let's go this, right? Example 5.4. Okay, a process control system specifies that temperature and pressure. Alright, you have two sensors, right? Temperature and also pressure should never exceed 160 degree and 10 kPa. Design an alarm system to detect this condition using temperature and pressure transducer with transfer function 2.2 mV per degree and 0.2 per kPa. Okay, so you want to design an alarm system. Okay, so you want to design an alarm system that you use two sensor, and then you set the level, right? This one. 160 degree and 10 kPa. Okay, you set the level. That means you say that, okay, now the temperature, okay, cannot exceed 160 degree. Okay, so 160 degree is on what voltage, right? And you have the pressure also cannot exceed 10 kPa. So kPa is on what voltage? Okay, we know that, right? So next, let's draw the temperature first, right? So we have the sensor, right? So the sensor will be like this. Okay, and then if we go to the comparator, right? So comparator, the symbol plus minus, so we know that is the comparator. Then it connected to here, and then this one you will have the output 1. Okay, let's put it in the output 1. Okay, right. So now the temperature have the transfer function 2.2 millivolt per degree. Okay, that means the input now will be degree, the output will be millivolt. Okay, settled. So right now your level is 160 degree, right? So 160 degree, that's mean 160 degree you time with 2.2 millivolt per degree. So what is it, guys? The value 160 degree time. Yeah, let me draw like this. Okay. So 160 degree time 2.2 millivolt per degree. What is this value, guys? Yeah, Johnny already got it. Wow, 352 millivolt. Okay, that means the level that you want to set it 160 degree is equal to 352 millivolt, right? So what you need to do, so you will have the V reference here. That means you want to set the limit, and this is your V in, right? Go to the comparator. So what you need to do is you need to add one supply, right? Plus minus here going to ground. This supply will give you 352 millivolt. Can you understand that? Which is, it will refer to 160 degree. Okay? Right. So that is where you set it, right? Where you set it. Okay? You can have another supply that have 352 millivolt. Alright. Or what you can do is you can have the potentiometer. Okay. So for example, this one you put it 5 volt. Okay. And this one it will produce adjust the potentiometer so that you can get it 352 millivolt. Okay. So what is this value? What is this value? It doesn't matter, so that you can have this output. You can put it here. There are two options here. You can use the potentiometer, right, to make it the voltage divider, right, and then you adjust to get it 352 millivolt. So we know that 352 millivolt will represent it 160 degree. Okay, right? So what will be the output one? Okay, for example, if I have the temperature it detect at that time is 170 degree. What will be the output one, guys? 1 or 0? Yes, is 1. Right? Which is equal to something like, if you put the 5 volt, okay. So if the output, the input will be 150 degrees, so you will got the output is 0. Okay, that is the concept of the comparator. Okay, done. So now we can draw for the pressure. Okay, for this one. Okay, let's draw the pressure. It also have the sensor. It have the sensor, and then it will go to the comparator, plus minus. So we don't know this one. And this one is output 2. Okay, done. So what is it? 0.2 volt. 0.2 volt for kPa. So the input is kPa. This output is volt. So now we have set the limit is 10 kPa. So you time with 0.2 volt over kPa. So you have a 2 volt. Okay. So this means you need to have another sources. So it said that is 2 volt here, which is representing 10 kPa. Okay. So if your input right now is 11 kPa, so you will got the output 1. If the input now is 9 kPa, so you will got the output is 0. Okay. So the last one, so let's derive all the circuit again. Okay, let's derive the circuit, overall circuit. Now you got it 2 here, and then So this is the temperature, this is the pressure. So the what is it, 2.2 millivolt, right? 2.2 millivolt per degree, and then this one is 0.2 volt per kPa, and then the reference, your reference now is 352 millivolt, which is represent 160 degree, and then this one is 2 millivolt, represent 10 kPa, plus minus plus minus. So this one the output 1 and output 2. Okay, this is your temperature and also pressure. Okay, but we are not finished yet. So the question said that temperature and pressure should never, that means both, right? Both cannot exceed 160 degree and 10 kPa. So what you need to add after this is you need to add gate, right? So you need to add the AND gate here, right? This is gate. Okay, so the last one will be your alarm. Okay, this is the alarm, right? What is mean by AND gate is you just need to multiply it, right? Okay, so when you do the alarm system and so on, you will have a truth table here. Okay, let me draw it first. 1 2 1 2 1. Okay, so now you will have the output 1 and output 2, and then you will have the alarm. Okay, so the truth table will show you the condition, what will be happen to the alarm. Okay, for example, output 1 you got a 0, output 2 also you got a 0. So how to get 0 at the output 1? That means maybe your temperature at that time is 150 degree. Maybe pressure at that time is 9 kPa. So both you will get a 0, 0. Okay. So what will be happen to the alarm when you put the AND gate here? So you just need to multiply. 0 times 0 will be 0. Okay. Right. So maybe output 1 at that time you got a 1 and output 2 is 0. So 1 times 0 is 0. 0, 1 will be 0 and 1, 1 will be 1. So 1, 1 that means you just have meet the question, requirement equation, that means both temperature and pressure cannot exceed the reference value. Okay, right? So that's why you use N. You also have another gate, which is what we call it the, what is it, guys? What is this gate? What did we name this gate? 2. What did we name this gate, guys? We have the AND gate and we have another one. What is this, guys? What did we call? Yeah, OR gate. Good job. This one is the OR gate. OR gate, that means you just need to plus it, right? Plus it. Okay. Okay. Plus, that means 0 plus 0 will be 0. 1 plus 0 will be 1. 0 plus 1 will be 1. 1 plus 1 will be 2. Will be 1. Okay. Alright. Okay. So that's it for the alarm system. Yep, we doesn't have any more notes. Okay. Alright. So I hope that it will be clear for you guys. It will be clear, very, very clear. Okay. Oh, most of you have left the meeting. Okay, about your test 1, yes, until this chapter. Your test 1 will be until this chapter, but we doesn't know yet the date for your test 1. Okay, I'm also don't know yet the date for your test one, right? We not get the schedule yet. All right. So I hope that today we have covered the signal conditioning A and also signal conditioning B. All right. I hope that it is clear for you all. Okay. And for this coming Thursday, we doesn't have class. All right. We doesn't have class, so I will see you on coming Sunday. Okay, because I need to go to Malacca, right? I have a project with Petronas, so I need to go there, right? So please, I will see you again on the next Sunday. Is it okay, guys? Or you want to have class? Oh no, I don't have class. Okay. Doctor, I may ask if possible you to send the writer news up. Yeah, sure. Did I send to the uh guy? Why is it SCMM? Okay. Oh, I never send that one for, right? Okay. I will send it to you. Right or not? Okay. Video in the learning, yeah. Yes. Have you uploaded or not? Okay, why the academic e-learning? Why the e-learning? Tam e-learning. I will share it. Oh no, I didn't upload it, right? Okay, I will try to upload it. Okay, right. Okay. Right. Please remind me, right? Sometimes I forgot it. Okay. Done. I will upload all the notes and also all the video into the e-learning. Okay, thank you guys. So be careful, right? For COVID-19. Okay. I see you again on next week on Sunday. Bye bye. Assalamualaikum.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Okay.